In this video, we are going to take a look at limits that increase or decrease without bounds. So we're now going to be exploring the asymptotes in the graph rather than the whole. So the first thing I want you to do is go to your y equals, type in the function 1 over x squared, and then just hit graph. So what you'll notice is we have on our graph here two asymptotes. We have our vertical and our horizontal asymptote. So when we go to graph this, I'm going to put two axes on here real quick. We know that we have a vertical asymptote going through at x equals 0 and a horizontal asymptote going through at y equals 0. Our main focus today is going to be the vertical asymptote. And our two branches of our graph are nested on the inside. So our domain for this graph is going from -infinity to 0. And then again from 0 to infinity. We're jumping over that vertical asymptote line. So our vertical asymptote is at x equals 0. And our horizontal asymptote is at y equals 0. So what we're going to take a look at right now is finding the limit as x approaches 0 of 1 over x squared. So we're going to use that table ask feature. We already have it in the calculator. And let's just pick some good values. So start at -0.1, 0.01, 0.001. We'll put 0 in there even though we know that's going to give us a bad answer. All right, so if we go over to our calculator, make sure you switch this over to ask if it's not already switched over. And then go to your table, and we're going to put in all of those values. Okay, so we're seeing the error message happening at 0, which we know is our vertical asymptote. And then we're seeing 100, 10,000, and 1e to the 6, which really just means that we have the 6 zeros after. So what's happening is on both sides, we are getting bigger and bigger and going towards the same direction. So that's important when we talk about the limit. Remember, this error message is because we have a vertical asymptote. So technically, the limit does not exist because if we're looking for an actual number answer, this just keeps on going and going on either side towards infinity. So we really want to look at what is happening here. And what's happening is we can make f of x greater than any positive integer, positive number actually, not integer, by taking x sufficiently close to 0. But not equal to 0. Therefore, these three little dots mean therefore, we say the limit as x approaches 0 of 1 over x squared is equal to infinity. Both sides are going towards positive infinity, so we say that. Infinity does not represent a real number. So a limit doesn't exist because infinity does not represent a real number. But what we're talking about is what the graph is approaching at that point. It tells us that the graph increases without bound. So we're going to try this again with a second graph. We'll just go right into the table. This one's a little bit different. Right now we're using the table feature to come up with these limits. We will be doing this algebraically. That will be in the next video. So our table, again, let's pick some values that are close to 1, but not equal to 1. So let's do 0.999. We'll pick 1 to put in the table, and then we'll do 1.001 and 1.01, enough so that we can see what's happening. We should already know we'll get the error message at 1. So let's change up our equation. And I'm going to do 1 divided by, parentheses, x minus 1. If you would like to use the fraction tool, you totally can. And then just delete some of these out so I don't have the extra ones in here. 0.99, 0.999, 1. And then 1.001. So the interesting thing about this table is we are seeing those numbers, but we're seeing one side going to the negative and one side going to the positive. So this is going to actually bring us back to our one-sided limit situation. The limit from the left side of g of x is equal to negative infinity, which means it decreases without bound. The limit as x approaches 1 from the right of g of x is equal to positive infinity, which means it increases without bound. So since those are different, we can't make a full statement about the limit as x approaches 1 of g of x. This is like the ultimate does not exist. So it already does not exist, but because the left side is decreasing and the right side is increasing, we can't put a positive infinity or negative infinity next to this limit. We're just going to stick with does not exist because it happens to go different ways on the different sides. All right, so in our next video, we will look at evaluating these analytically. We can't really do much algebraically, but just kind of thinking about what's happening with the table without actually plugging the values into the table.